Hello students, this is question from JEE Advanced 2026. This question is from the chapter Atomic Structure. It is a moderate level question based on the energies of orbitals. You have to compare the energies of various orbitals. I will read out the question. The 2s and 2p orbital energies of hydrogen atom are E2SH and E2PH respectively, and the 2s and 2p orbital energies of lithium atom are E2SLi and E2PLi respectively. The correct options about the orbital energies is are. So you have to compare the energies, which order is correct and which order is not correct. You have to choose the correct orders. So first option A is energy of 2s of Li is less than energy of A. Option is energy of 2s of lithium is less than energy of 2p of lithium. Lithium is a multi-electronic atom. It has 3 electrons. So, for comparing the energies, we have to consider the Aufbau principle. So, we have to use Aufbau principle or N plus L rule for comparing the energies. So, energy of 2p will be higher as compared to 2s. Here, we have to use the normal sequence 1s, 2s, 2p, 3s in this way, or you can use N plus L rule for multi-electronic atoms or atoms having more than one electron. So here we have N plus L, 2 plus 0 is equal to 2, and here we have N plus value of L for P is 1, 3. So higher the value of N plus L, higher will be the energy. So this option is obviously correct. And let's come to the second option. Second option is B option is energy of 2s of hydrogen is equal to energy of 2p of hydrogen. So B option is energy of 2s of hydrogen is equal to energy of 2p of hydrogen. So hydrogen is hydrogen has only one electron. It is a single electron species. So in this case, according to the Bohr model, I can write the energy value is equal to minus 13.6 z square by n square. So the value depends only on the value of n and not on the value of L. So for one electron species, value of energy depends only on the value of n. So for 2s and 2p, the value of n is 2 for both. So here we have n is equal to 2, n is equal to 2. So this both energies are equal, and option B is also correct. Next, coming to the C option, we have to compare the energy of 2p of hydrogen and 2s of lithium. So in this case, you have to use a simple logic that as the distance from the nucleus increases, energy also increases. Distance from nucleus increases, energy increases. Or simply, greater the value of Z, higher the value of Z, lower will be the energy. For similar, so as the value of Z increases, this negative number become larger. Larger negative number is lower, means that its energy is lower. So as Z increases, or simply you can understand it in this way, as the Z increases, the attraction from nucleus increases and electron come closer to the nucleus. As Z increases, electrons are closer to the nucleus because the attraction from nucleus is higher. So here we have, as Z increases, electrons are closer to the nucleus, and if electrons are closer to the nucleus, then they have lesser energy. So in C option we have to compare the energies of 2p and 2s. 2p of hydrogen, energy of 2p of hydrogen is less than energy of 2s of lithium. First, we already know energy of 2p of hydrogen is same as energy of 2s of hydrogen. So I will put this value here. So the comparison will be easy because here it is 2p, here it is 2s. If I make it 2s, then comparison will be easier. So I am putting this value from this equation here. So we have E of 2s of hydrogen less than E of 2s of lithium. So for 2s orbitals, we have to compare the energies. Value of Z for lithium is 3 and value of Z for hydrogen is 1. So for lithium, we have higher attraction from the nucleus. So 2s orbital will be smaller in size. Or simply using this logic, as Z increases, energy decreases as electrons or orbital come closer to the nucleus. So higher the value of Z, its energy will be lower. But here it is given that its energy will be higher. So C option is wrong. So correct order will be energy of 2s of lithium is lower than energy of 2s or 2p of hydrogen. This is correct. Here it is a wrong order. So answer option C will not be a answer. And in D we have energy of 2s of hydrogen is higher than energy of 2s of lithium. So in D option we have energy of 2s of hydrogen is lesser than energy of 2s of lithium. Sorry, it is higher than energy of 2s of lithium. So using this logic, as Z increases, energy decreases. As Z increases, value of Z is 3 here and it is 1 here. As Z increases, energy decreases. So this option is obviously correct. Lithium nucleus is attracting more this orbital. For 2s orbital, the attraction from lithium nucleus is higher. So this orbital will be smaller and smaller orbitals have lesser energy. So option D is also correct. So this is the multiple choice question and correct options will be A, B and D. That's it. Thank you.